Approximately 390,000 flights transit the North Atlantic every year, with approximately 80% routing between Shanwick and Gander Oceanic airspace. Of these flights, approximately 50% route via the organised track structure. Both Shanwick and Gander are MNPS airspace between flight level 285 and flight level 420. The current separation standards for aircraft operating in oceanic airspace are 1,000 feet vertically, 10 minutes longitudinally, although this may also be reduced to as little as 5 minutes in specific circumstances. For example, if the aircraft in front is faster at ocean entry, or, once within oceanic airspace, if both flights are eligible for reduced longitudinal separation minima, or RLong, and 50 nautical miles laterally. For ease of application, this is established using 1 degree of latitude. Each day an organised track structure is designed. This is a composite of the preferred route messages received from airline operators, also taking into consideration other factors, such as weather, airspace restrictions, and traffic densities. All tracks are currently spaced by a minimum of 1 degree of latitude. The North Atlantic organised track structure requires all aircraft to be data link mandate equipped when operating on any track between flight level 350 and flight level 390. But commencing in November 2015, advancements in aircraft avionics will result in a trial reduction of the lateral separation between organised tracks in North Atlantic airspace. Aircrew have the ability to select the requisite navigational capability according to the airspace. RNP-10 requires the use of 2 long-range navigation systems, and a lateral total system error, this is the difference between the true position and the desired position, to be less than 10 nautical miles for 95% of the total flight time. RNP-4 also requires 2 long-range navigation systems, but this time requires the difference between the aircraft's true position and desired position to be less than 4 nautical miles for 95% of the flight time. For RLat operations, prior to entry into North Atlantic airspace, procedures require crews to check that RNP-4 is selected as the current navigational capability. This improved navigational ability has facilitated a trial in reducing the separations required within the oceanic environment. Still maintaining 1,000 feet vertically, longitudinal separations can now be reduced to 5 minutes at ocean entry point, even if both aircraft are maintaining the same speed, providing both aircraft meet the requirements for RLong, and now 25 nautical miles laterally. For ease of application, this is applied using half degrees of latitude. With smaller separations between aircraft, more aircraft can be cleared at their optimum levels. This could save 52,000 metric tons in greenhouse gas emissions. That's the equivalent of 14,000 flights in a Boeing 767-300 from London to New York. In order to accommodate this new reduced lateral separation standard, new half-degree reporting points will be established along the Shanwick and Gander oceanic boundaries. Focusing on the Shanwick boundary, reporting points on the Scottish Shanwick boundary are due to become active for flight planning purposes in September 2015. Whilst those on the Brest-Shanwick boundary will become operational in November 2015. If we zoom in on the Shanwick and Brest interface, operators are reminded that on days when traffic loadings are high in the south of Shanwick airspace, information that can be found daily on the Shanwick website, it is advisable to file through northerly entry points if routing towards Gander airspace. Meanwhile, aircraft routing to South American and Caribbean destinations are better served filing through southerly entry points. This avoids aircraft having to be rerouted at ocean entry point to avoid crossing in oceanic airspace. Phase 1 of RLat implementation will involve the creation of a single additional half-degree track within the organised track structure. RLat tracks will be defined in reference to half-degree coordinates. This is scheduled to go operational in November 2015. The introduction of half-degree waypoints increases the importance of entering coordinates correctly. In order to prevent any navigational errors as a result of incorrectly entered latitudes and longitudes, and regardless of the FMC waypoint format, Crews are reminded to follow relevant procedures when entering and checking coordinates in their FMC. These procedures should be conducted during pre-flight, upon receipt of a revised oceanic clearance, and approaching an oceanic unnamed waypoint, to include verification of the next and next plus one waypoints. The insertion of an additional half-degree track in the previous example would result in RLat airspace of tracks Bravo, Charlie and Delta between flight levels 350 and 390. Any aircraft filing on these tracks at these levels will require the appropriate RLat eligible equipment. Phase 2 is scheduled to commence approximately 6 to 12 months after the implementation of Phase 1. This involves all tracks within the organised track structure being eligible for half-degree separations. Again, aircraft without the organised track structure should continue to flight plan and operate with reference to whole degrees of latitude. RLat tracks only exist at flight levels 350 to 390. The normal track separation of 1 degree continues to exist for all other altitudes. Implementation of RLat SM will not require any alteration of organised track structure promulgation procedures, except that Note 3 of the OTS message will be reserved for RLat tracks, and any RLat tracks will be underlined. Suitably equipped aircraft will be able to flight plan on the RLat track defined by half-degree coordinates, on either of the adjacent tracks defined by whole-degree coordinates, or to cross the RLat tracks. Aircraft will not be able to join or partially follow any RLat track, flight plan onto an adjacent track defined by whole degrees of latitude, and subsequently be rerouted onto an RLat track defined by half degrees of latitude, prior to the ocean boundary. However, it will be possible for an aircraft to be rerouted onto an RLat track via CPDLC once the aircraft is within oceanic airspace. Aircraft should continue to utilise the standard lateral offset procedure whilst operating within RLat airspace. Operators do not need to apply to utilise RLat tracks. However, aircraft will only be eligible for the application of RLat provided that they meet the communication, navigation and surveillance criteria, in addition to the equipment required for operation in the oceanic environment, for example HF. RLat tracks are coincident with MNPS airspace, hence aircraft will need to be MNPS equipped. Aircraft will also require to be RNP4 approved. Aircraft will need to be ADS-C equipped and have contracts established with the appropriate oceanic centre. Aircraft will also need to have CPDLC. In order to be eligible for RLat separations, an aircraft's data link capabilities and navigational status must be included in the flight plan. Prior to the ocean boundary, aircraft establish ADS-C and CPDLC connections with Shanwick or Gander. Crew should ensure ADS-C and CPDLC connections are established, as these connections are a requirement of being cleared on an RLat track. This pre-boundary ADS-C connection will further reduce the risk of navigational errors within the ocean. Traditionally, lateral gross navigation errors have been prevented through the requirement for crews to report the aircraft's current position, as well as the next position and the subsequent position. However, this procedure is of only limited use for aircraft that enter the ocean at an incorrect position, or immediately begin routing towards an incorrect position, as by the time this report is received, the aircraft may already have left its cleared route. RLat provides the ability to improve this lateral conformance monitoring in two ways. Firstly, the pre-boundary ADS-C logon will be accompanied by an interrogation of the aircraft's FMC, in order to confirm that its first projected positions within the ocean are as expected. Secondly, shortly after entering the ocean, a confirm assigned route message will be sent via CPDLC to the flight, to which flight crews will be expected to respond by downlinking the assigned route held in their FMC. This allows controllers to conformance check the aircraft's route across the ocean and query any discrepancy and rectify as necessary. If a flight experiences a failure of an RLat-required CNS system after departure but prior to entering RLat airspace, for example the loss of an ADS-C connection, the flight should contact ATC and request a revised clearance that will keep it clear of RLat tracks between flight level 350 and flight level 390. If a flight experiences a failure of an RLat-required CNS system while operating within RLat airspace, ATC must be immediately advised. Such flights may be re-cleared to exit RLat airspace, but consideration will be given to allowing the flight to remain in the airspace based on tactical considerations. Further details can be found in the Global Operation Data Link document,